Facilities planning and network design are strategic activities that determine how logistics resources, infrastructure, and inventory are positioned to support customer requirements while minimizing total supply chain costs. Network design involves selecting the optimal number, type, location, and capacity of facilities, along with the transportation links that connect them. These decisions influence customer service, inventory investment, transportation expenses, and operational flexibility for many years. Because network design affects both fixed and variable cost structures, organizations must carefully evaluate alternatives before implementation. A well-designed network balances transportation, warehousing, and inventory trade-offs while supporting organizational strategy, profitability, and responsiveness to changing market conditions. A formal network design process helps organizations move systematically from their current state to a desired future state. The process begins by establishing the rationale for transformation, defining strategic objectives, identifying customer requirements, and creating cross-functional support for change. Organizations then analyze current operations, develop future state scenarios, evaluate alternatives, and prepare implementation plans. Network design projects often involve significant digital transformation initiatives, capital investments, and organizational changes. Successful implementation requires leadership commitment, stakeholder alignment, project governance, and detailed planning. By following a structured methodology, organizations can manage complexity, reduce risk, and ensure that network design decisions support long-term strategic goals. Environmental scanning is an essential part of network planning because external conditions strongly influence logistics performance and investment decisions. Steeple analysis evaluates sociocultural, technological, economic, environmental, political, legal, and ethical factors that may affect logistics operations. SWOT analysis complements this approach by identifying organizational strengths, weaknesses, opportunities, and threats. Together, these tools help organizations understand market conditions, customer expectations, regulatory developments, competitive pressures, and emerging risks. The insights gained from environmental scanning support informed decision-making and strategic alignment. By continuously monitoring internal and external factors, organizations can design logistics networks that remain resilient, adaptable, and capable of supporting future growth and changing business requirements. Effective distribution network design must be customized to fit an organization's unique logistics requirements and customer value propositions. Customer service expectations, product characteristics, demand patterns, market geography, and transportation requirements all influence network structure. Organizations apply total cost integration and systems thinking philosophies to evaluate trade-offs among transportation, warehousing, inventory, and customer service costs. Rather than optimizing individual functions, logistics professionals seek the lowest total system cost while maintaining required service levels. Business strategy and customer transportation requirements guide decisions regarding the number of facilities, their locations, and the services they provide. The objective is to create a network that delivers competitive service while generating sustainable profitability. Inventory placement is a critical component of network design because it directly affects customer service, transportation costs, and working capital requirements. Organizations determine where inventory should be located, how much inventory should be stored at each facility, and how frequently replenishment orders should occur. Customer service goals often drive warehouse proximity decisions, while transportation costs and inventory carrying costs influence facility consolidation strategies. Determining the threshold service level involves identifying the lowest cost network capable of meeting customer expectations. Adjustments to safety stock levels, delivery frequency, and facility placement create trade-offs that must be analyzed carefully. Successful network designs balance inventory availability with total logistics cost objectives. Initial network designs must be refined to account for deployment considerations that affect long-term operational success. Facility location decisions require analysis of proximity to customers, suppliers, ports, transportation infrastructure, and industry clusters. Additional considerations include labor rates, labor availability, taxes, sustainability objectives, quality of life, regulatory requirements, and government incentives. Site acquisition decisions occur at national, regional, and local levels and require balancing multiple competing priorities. Organizations frequently use tools such as cost-volume analysis and weighted factor rating methods to compare alternatives objectively. These techniques help quantify both financial and non-financial factors, enabling decision-makers to identify locations that best support strategic and operational goals. Modern network design increasingly relies on sophisticated analytical tools to evaluate complex trade-offs and optimize decision-making. Optimization models identify the best solutions based on defined objectives and constraints, while simulation models test network performance under various scenarios. Heuristic models provide practical solutions when problems become too large or complex for exact optimization techniques. These tools help organizations evaluate facility locations, transportation routes, inventory strategies, capacity requirements, and service level alternatives. After implementation, network performance must be validated through forecasting, benchmarking, financial analysis, and operational metrics. Organizations compare actual performance against predefined goals and adjust designs as needed. Continuous validation ensures that the network remains aligned with strategic objectives and continues to deliver expected value. Successful facilities planning and network design create a logistics infrastructure capable of supporting organizational strategy, customer expectations, and long-term growth. By combining structured planning processes, environmental analysis, total cost integration, inventory optimization, site selection methodologies, and advanced modeling tools, organizations can design resilient and efficient logistics networks. These networks provide the foundation for operational excellence, competitive advantage, and supply chain adaptability. Because market conditions, customer demands, and business strategies continually evolve, network design should be viewed as an ongoing strategic capability rather than a one-time project. Organizations that regularly assess and refine their logistics networks are better positioned to manage change, control costs, improve service levels, and achieve sustainable supply chain success.